In my previous Commodore episode, you saw that the Commodore PC-1 refused to start. The PSU didn't do anything anymore. So, in order to get the machine up and running, I hacked together an external power supply based on an ATX power supply by creating this kind of adapter between the ATX pinout and the Commodore PC-1 pinout. Now, I got the machine to start, but obviously this is not a final solution. So I went ahead and looked for a replacement power supply and found this one. Now before we get started on this video, I do want to issue a word of caution and explain some general safety issues when dealing with these type of switch mode power supplies. You have to remember that we are dealing with AC power here, and that operates at higher voltages than the voltages that you typically see inside a computer. These voltages from the switch mode power supplies can be dangerous, lethal even. Touching the components can be extremely dangerous. If you're not comfortable checking these types of circuits with a multimeter, then don't do it. Get somebody to help you with some more experience, learn from them. Don't just start probing around to avoid shorts, as shorts on these voltage levels are extremely dangerous. Keep in mind that the input capacitors on this circuit can hold a very high charge, up to 400 volts. If you don't want to be zapped by 340 or 400 volts, please ensure that the cap is discharged, because you will see the actual hot voltage between these two pins and you don't want to come in contact with them. Now, I'm not a trained electrician, nor am I a trained teacher, so if you want to safely see how to discharge a capacitor, I highly recommend you checking out the video in the description. It doesn't involve discharging capacitors using a screwdriver, but rather uses the appropriate way to do it, using a resistor. If you let the power supply sit for a couple of hours after the AC power cord has been plugged in, it should be discharged. But always double check with your multimeter before starting to work on it. Now, I've opted not to repair this power supply because there could be any number of things wrong with it. The input capacitor could be bad, although I don't think this is the case. There could be issues with the diodes. There could be an issue with the silicon NPN power transistor. Can be an issue with this control IC for the transformer. Can be an issue with the transformer itself. And over on the DC side, any number of the capacitors found here can be bad. So yeah, it would take a lot of effort to check everything. A lot of these components are very difficult to find these days. Now, this original power supply dates from September '87. I think it's about time for a replacement, despite the fact that you don't see any catastrophic failure or burn marks. It's probably just a component that died given the old age of the power supply. So back to the task at hand. Now, the first thing that I did was I checked to see if the new power supply would be sufficient. So I hooked up my multimeter to check the power consumption of the PC-1. So I've measured the two 5-volt lines using two multimeters because I couldn't get it to work with one multimeter. So I hooked up the black leads to the two 5-volt lines coming out of the computer and the rest to the PSU. And as the computer was starting, I could see that there was one rail which had a consumption of about 1.4, 1.5 amps, and the other one was at 300 milliamps. So I did a couple of tests, I ran some benchmarks, I played some games, and the power consumption was pretty much averaging out on 300 milliamps on the one hand and 1.4, 1.45 on the other 5-volt lines. So the new PSU was definitely up to the task as a replacement kit for this Commodore PC-1. Now, the old power supply I'm not going to fix, but I am going to be reusing the harness, of course. It has the power switch, it has the power inputs. It also has the wiring harness that is used to power the Commodore PC-1. So it's just a matter of removing the PCB from this harness and swapping in the new power supply. So we're going to be removing the AC power lines. So that's the live and the neutral wire clearly marked on the PCB and coming out of the power connector from the harness. So I'm going to use these set of tweezers to hold the cable in place, and then use my soldering iron to heat up the pad and remove the wire. So on this PCB there are two live wires and two neutral wires, one for the two power inputs, well, one power input and one power output for the monitor. So I'm going to be removing 4 wires in total to remove the PCB from the harness. So with that out of the way, let's take a closer look at the actual harness. So we have all the wires coming out of the power inputs. We have the power switch. So we'll be hooking those up to the new power supply and finding a way to attach the new power supply onto this harness. So there are a couple of screws, so we'll need to see how it will all fit together. I am interested in recuperating this wire harness here because it obviously has the pinout for the Commodore PC-1. So I'm going to be desoldering all of these cables. So we've got the ground, we've got the 5-volt lines, we've got the plus 12 volts and the minus 12 volt that we are going to be removing from this PCB. So I'm again picking up my tweezers and heating up the pads to remove all of the cables. So starting with the ground lines. So there are 2 ground cables. It doesn't take too much effort to remove them. Here are the 2 5-volt lines on the PCB. So sometimes when you're having trouble getting the cable out of the PCB, you can use this desoldering pump to remove some of the excess solder from the pads so that you can get the cable out more easily. And here we have the plus 12 volts and the minus 12 volt cables that we're also going to be removing. So now we've completely detached the wiring harness from the PCB. So now it's time to take a look at the new power supply that we'll be using. So as you can see, it's a small embedded switch mode power supply that should fit the case quite nicely. It's very compact, it's modern, it has the necessary output voltages that we need. So it should be very much up to the task. Now I've printed out the datasheet of this power supply. So it's a 60 watt embedded power supply. Now in the datasheet you can find the individual output voltages of this particular series. So we have the RPT60B with 3 output channels, 5 volts, 12 volts and minus 12 volts. And here you can see the rated current for each output voltage. Now we need to ensure that the rated current corresponds to the original power supply's rated current. So I've downloaded the schematic from the original power supply from the technical manual. So let's compare it to the new power supply's rated currents. So we can see that the rated current of the new power supply exceeds the one from the original one, except for the 12 volt rail, where the new power supply has 2 amps and the original one had 2.2 amps. But that shouldn't be that much of an issue. This JST connector will be used to hook up the AC input, the live and the neutral wires, using these crimp terminals. Most manufacturers of these power supply units, they tell you what kind of connectors and crimp terminals that you need to use. So I'm going to be using 2 wires here for the power. I'm just going to be stripping them. And I'm going to take 2 of these crimp terminals. They usually come like in packets of 100 or 200. So you just clip them off like this. Now if you look closely to these crimp terminals, you see that there are 2 tabs. There's an inner tab and a larger outer tab that needs to be crimped. So the inner tab is for holding the actual wire in place, and then the second one is to have some additional strength on the non-stripped cable. So I have a generic crimping tool which is not really made for this particular type of crimp terminal, because every crimp terminal typically has its own set of specialized tools that cost a lot of money, but I'm just going to be using my generic one. So I'm going to be crimping it. And as you can see, the inner tab has been crimped pretty nicely, so the wire is pretty much hooked up. but the outer tabs are still a bit too loose, so they won't fit the actual connector. So as you can see here, I'm having trouble hooking it in, so I really need to apply pressure, and that's not a good thing. So you should never apply too much pressure when attaching such a crimp terminal onto the actual. So possibly it will require some rework on the outer tabs to get them tight enough or small enough to fit the actual connector, so that you can hook in the wire without applying too much force. But here you can see we have a good connection. It's made its way well into the contact, and we're good to go. So we're going to do the second one. Again, we take the crimp terminal, put it in the crimping tool, put the wire in, apply pressure. We again have the same problem that the outer tab isn't set up correctly, so we do it for a second time until we do a visual inspection and see that it's okay, and then we can add it to the actual connector. So again, I don't have to apply too much force. It basically slides into place, and we have a good connection. So we are going to be attaching these two wires onto the original harness. So on the original harness we had a on-off switch, which basically cuts off the live wire. So when you plug in your AC power connector onto the power supply, there is this live wire, a ground wire, and a neutral wire. So the live wire is disconnected here using the power switch. So when the power switch is off, the AC is pretty much disconnected. So the neutral is still connected, but there isn't going to be any current flowing through the wires. So I'm just going to check with my multimeter to see how to validate the actual wiring. So the live wire here coming from the AC adapter will only reach the PCB when the power switch has been turned on. So I'm looking for a way to place the new PCB onto the harness. So I think it's going to go that way, because we don't have a lot of extra wire on the other harness that we pulled out, and we do need to cross some distance to get to the Commodore PC-1. So it's always handy to have the documentation of the power supply unit at hand so that you can always check the pinouts. So here we see the live and the neutral wire. So we're going to be attaching those to the original harness. So I've taken some pictures also. I've annotated them to make sure that we're connecting the right wires, because we are dealing with AC power here, so that's not something that you want to mess with. So I'm just going to strip the wires. I'm going to tin them so that they make a better connection when connecting them to the power switch here, which will complete the live wire when turned on. Again, always check with your multimeter to see where continuity is, where everything ends up, just to make sure that you are hooking up the correct wires. So here I'm taking the neutral wire coming out of the power supply. I'm going to tin it and attach it to the neutral wire on the actual AC input connector. So again, we want to double check that all of our connections are made in the right way. So we're going to be doing continuity checks on the live and the neutral wire to make 100% sure that they correspond to what the new power supply is expecting. Now another important aspect of the wiring is the ground connection. So the PCB has two holes here which can be used to attach a ground connection. And we're going to be attaching it to the chassis ground of the actual power supply unit harness. So the screw that you see here between the two power connectors, hooking up the two green-yellow wires, is the ground connection. So we need to hook that up to our power supply unit. Now this is typically done using these screw holes on the chassis, but they don't really correspond to the holes that we have on our new power supply unit. So we need a different solution. So I'm going to be soldering two wires up to the ground connection from the new power supply unit. Now, normally you would attach a ground wire using a screw just to make sure that it's mechanically sound. Now I don't have these type of connectors here, so I'm just going to be soldering the wire onto the PCB directly. I'm assuming that this PC won't vibrate all of that much, so the mechanical stability won't be that much of an issue, and the solder joint would be strong enough to hold this, this particular ground connection. So I'm just going to strip 2 pieces of wire so that we can attach them to the chassis ground of the power supply harness. So with that in place, we're ready to hook up the 2 ground wires onto the ground connection of the power supply harness. So we'll go ahead and do that. So with the power cables connected, so the live, neutral, and ground connection, it's time to take a look at the DC side of things. So here I have the original wiring harness, and there are a total of, let me see, 7 connections that we need to provide. So I'm going to be stripping these cables, properly tinning them so that I can add them to a connector on the DC side. Now, unfortunately, I ordered the wrong type of connectors here. There is a 6-pin connector provided on the power supply, but I ordered an 8-pin one, but we can make that work. So checking the documentation, I've written down all of the voltage for the 6 pins on the DC side. So I always like to have that documentation handy, also some pictures of the PCB with the pinouts, just to make sure that we are hooking everything up in the right way. So again, we're going to be crimping the terminals onto the stripped wires, and we're going to do that for all of our connections. So we have the 2 grounds, we have 2 5-volt rails, we have a 12-volt rail, and the minus 12 volts. Now, because I've bought an 8-pin connector to fit a 6-pin interface, I'm going to be writing down the actual pinout on the documentation here so that I don't screw anything up. So the outer pins will not be used on the connector, so I have 6 pins, and I'm going to be mapping them to the voltage outputs of the power supply. So I'm going to be writing that down as I insert the wires and the crimp terminals onto the connector. So here I have my connector, and I'm going to be adding the wires one by one. So starting with the 5 volts, the second 5 volts, a ground connection, another ground connection, the 12 volts, and the minus 12 volts. So here we go. We have the Commodore pinout on the one side and the new power supply pinout on the other. So now first power on test. I have my multimeter ready. I have hooked up the ground terminal or the ground probe to the Molex connector, which is an easy connection. I have plugged in the AC power cord. Nothing has exploded so far, so that's good. So now I'm going to be carefully flipping the switch without touching any metal. So far so good. So let's take the multimeter and check some voltages. So I have the documentation here. I have the pinout of the Commodore PC-1 connector. So we should have 5 volts here, and we do. Another 5 volts, excellent. The third one is not connected at all, so that will be floating. We have 12 volts, 11.8, which is okay. Minus 12 volts, also okay. And 2 ground connections. So these connections appear to be okay. There's no smoke, nothing has exploded. So yeah, I guess it's time to put it into the Commodore PC-1. Now I've added some electrical tape to make sure that there aren't any shorts, but the PCB is pretty well secured, even if it is only secured using one single screw. So I am going to be adding the power supply housing back on again, and we should be good to go. So time to put it in. As you can see, there's not a lot of wire to reach the actual Commodore PC-1 mainboard connector, so it's good that we placed the power supply like we did. So I'm going to be adding it into its appropriate place. I think it needs to be secured by only 2 screws. And there are some extra ground connectors that we can use here. One coming from or I think 2 coming from the disk drive, so that the disk drive is also connected to chassis ground. So I'm going to be adding the screws here to put the power supply unit back into its place. There are 3 screws in total. The second one being over here, where we have a ground terminal coming from the disk drive that we will attach to chassis ground like this. Now in order to put the third screw in, I need to pull down the shielding, but before I do that, I'm just going to do a quick check using my multimeter to see that the voltages are still okay. So I'm going to be hooking up the AC power cord, switching the power supply on, and checking the voltages one last time because I want to be absolutely sure that everything is hooked up correctly. Okay, so now we can pull down the shielding back again. So we need to do that in order to get the third screw in of the power supply. And the shielding, there's a hole to put the power supply connector back in. But we're first going to be holding the shielding back into place using this screw. And then all we need to do is plug in the power connector to the main board and the Molex connector to the disk drive. So time for a first power on test. We'll add the AC power cord, flip the switch, and it's booting. So I'm just gonna let it do the memory test. I have a MS-DOS boot floppy into the disk drive, so it should boot into DOS. So it's accessing the drive, it's reading from the drive. And yep, seems to boot just fine. So it's finally time to put the lid back onto this computer so that we can put the monitor on top and have an actual go at playing around with the PC on a software level. So it's always a bit finicky to get these lids back on. I have this with most Commodore systems, that it's not that straightforward to put everything back together, but you know, in the end it always works out. And here we have our lid back on completely. So all we need to do now is screw in the 4 screws at the bottom, and we should be able to start her up again. And sure enough, there she goes. On the monochrome black and white monitor, we see the Commodore PC-1 and its startup procedure, ready to play some games. So one of the games that I wanted to try was Blackout from California Dreams. It supports Hercules mode 720 by 384, And I wanted to compare it when I will be hooking up a CGA monitor to it to see the difference. So as we see the California Dreams splash screen loading up, we should see the iconic blockout startup sequence. And here it is. So it's actually looking very sharp on this monochrome Commodore monitor. But I am going to be speeding up the footage here because it's not the world's fastest PC, obviously. So let's look at some gameplay. We'll start at level 0. And again, very sharp graphics, the high resolution, Hercules doing its job very well. And yeah, really nice to see these high quality Hercules games running pretty well on this Commodore PC-1. Now another thing I wanted to try was another classic, which is Arkanoid, Revenge of Doe. So I couldn't get the first version of Arkanoid to run on this Hercules adapter, and even the second one started complaining that it didn't detect a Hercules mode, despite the fact that it obviously works in Hercules. So I was a bit surprised to see that. So what we're seeing here is obviously a Hercules mode graphics. So yeah, don't really know why it's complaining. Perhaps it doesn't properly detect the Paradise video chip. But yeah, the game runs pretty smoothly. It's again high res. It actually looks a lot better, as you'll see later, than the CGA version because it is higher resolution, and the individual colors of the blocks that you see here are much clearer than in the CGA version. So the Commodore video connector supports both monochrome and CGA, and you can set it using these dip switches. So if I set dip switch number 3, it should output CGA. So I've hooked up a Commodore CGA monitor onto the system, the Commodore 1901. And I was a bit surprised that it didn't work. I saw a blinking cursor, but that was pretty much it. So I expected to see the boot screen here, but I didn't. So I checked the technical manual of the Commodore PC-1, which was in German, by the way, so I had to do some translation. But I found that it wasn't only the switch number 3 that needed to be changed, but there was another switch as well. So after doing that, the PC-1 started giving output on the CGA monitor, and we could try out some games. Now the first game that I wanted to try was the original Arkanoid, because this doesn't have Hercules support. So I thought that this would run just fine in CGA mode, but apparently it had some issues detecting the CGA video card for some reason. So yeah, I was a bit surprised to see that this didn't work here. So I wanted to see if I had the same issue with Arkanoid 2, Revenge of Doe. So let me start it up, and it should give me a prompt to select the video mode. So we're not going to be using Hercules, but we're going to be opting for CGA. We get a warning pop-up that CGA is not detected, but the game does start in CGA mode, so that's good. But again, there must be something in the way that it detects this this video chip, which is not your typical chip that you find in your IBM PC compatible. But it does seem to work just fine, so that's good. And to conclude, I wanted to show you blockout in CGA mode and just let you see a different side of CGA. You know, not the horrible colors that you're used to, but blockout uses the different CGA color palette. So to match the California Dreams splash screen, uses green, yellow, and red colors. So I'm speeding up this footage again because, again, it's not the fastest PC in the world. So I hope you've enjoyed this video. At last, we've got the Commodore PC-1 back up and running again with a new power supply, ready to play some games. We've checked out the Hercules mode, the CGA mode, and there's going to be a final installment of this series where we're going to be taking a closer look, do some benchmarking, and see what other stuff we find out on this neat little PC. So thanks for watching, and see you guys soon. Bye bye.